Before we define what algorithms are in machine learning, we need to understand why machine learning, powered by algorithms, is so crucial today. Machine learning is the set of techniques and tools enabling the recent AI technical revolution, which is causing AI to be featured everywhere as a solution. You might recognize this at this stage as the emergence of AI models that you can interact with using prompts, the likes of large language models from ChatGPT, Microsoft or Google. It is the use of machine learning tools, techniques, and specifically algorithms that allow the creation of these AI models. The algorithms allow machines to self-learn from vast amounts of data. Using the algorithms, the machines are trained to identify patterns and connections between the data in the datasets. Neural networks are trained to capture these patterns by adjusting internal parameters, forming the core of many AI models. Thanks to advancements in both hardware and software, we can now utilize advanced deep learning machine learning algorithms to work with massive datasets, creating even more complex multi-layered neural networks, the likes of which power some of the most powerful AI models on the market today. Some models that use algorithms like decision trees or linear regression don't rely on neural networks, but instead use other statistical techniques. Let's now take a step back and look at how we actually use these machine learning algorithms to produce these AI models that are powering everything from chatbots, LLMs, and AI agents to generative AI. The machine learning algorithms analyze data and spot the subtlest patterns between the data, and they self-learn these patterns and store what they have learned into an AI model. When we have what we call labeled data, where we label the data to indicate input data and output data, machine learning algorithms can detect the subtlest patterns in the input data that lead to a specific output, allowing the development of AI prediction models that can predict one dataset from another using the patterns stored within the neural network or a statistical model stored at the core of the AI model. Remember, this is all possible only because of machine learning algorithms that can work autonomously, repeatedly identifying data patterns and linking them to output while working through terabytes and petabytes of data. This could be data on users' music listening habits, allowing for the creation of an AI prediction model to identify other artists they may enjoy. It could involve data on patient DNA and hereditary diseases to create an AI prediction model that can forecast future health issues. Without these algorithms that help machines learn independently, relying on a person or a team to work through the same amount of data to recognize the same data patterns would be an impossible task, let alone expecting a person to reorganize and condense all the data patterns learnt into a neural network of interconnected nodes, a process more commonly known as training an AI model on datasets. This AI model can then be used to analyze new input data to predict the related output data accurately, a process more commonly known as inference, where an AI model is used to make predictions, decisions, or classifications on new unseen data. Obviously, behind the scenes, a lot more happens as part of this inference. When data is received in the form of text, image, audio, or structured data, it is cleaned and transformed into a format that the AI model understands, which can involve tokenization, normalization, encoding, and padding. At the core of the inference, the pre-processed data is passed through the trained model, where layers of neurons process the data, and each layer applies learned weights and biases from training to process the input. The final part of the process produces the result, which might be a classification in the form of identifying an object in an image, or in the form of regression, where we predict a specific type of output, or in the form of some sequence generation, where, for example, we generate a response to a question presented to a large language model. The creation of these AI models is again only possible thanks to machine learning algorithms. The good news is that there are many types of algorithms available to work in different situations and with varying types of datasets. A group of machine learning algorithms falls into the category of supervised learning algorithms, and they are called supervised because the dataset contains labeled data. For example, input data is clearly labeled, and the expected output data is also clearly labeled. These machine learning algorithms then only have to identify the data patterns between related input and output to create an AI model that can perform tasks such as prediction. Working with this type of machine learning algorithm to create an AI model, however, requires some effort in terms of preparing the training data. Supervised learning requires labeled data, which can be time-consuming to prepare. This sometimes limits dataset size. Generally speaking, the more data you have for AI model training, the better the AI model will perform. The good news is that there is another category of machine learning algorithms called unsupervised learning algorithms designed to work with even larger datasets. This is because they don't require the labeling of the data, an effort which usually ends up limiting the amount of data available for AI model training. Instead, unsupervised learning algorithms are designed to work with large datasets to identify patterns within the dataset and relationships between data points without the need for labeling. Unsupervised learning algorithms are also better at identifying hidden data patterns because they are not restricted to correlating specific inputs with specific outputs. Therefore, an AI model can be developed that understands subtle and nuanced patterns within the data in more detail. There's also another category of machine learning algorithms that combines the advantages of both supervised learning and unsupervised learning, and this group of machine learning algorithms is appropriately called semi-supervised. The basic idea with the semi-supervised category of algorithms is that the algorithms can use both a labeled dataset, where you identify the input data and output data you are trying to correlate, but also have the ability to use masses of unlabeled datasets. The labeled dataset provides the algorithms with a head start, as labeled data helps guide the model's learning, enabling it to generalize patterns across unlabeled datasets more effectively. There's also another category of machine learning algorithms called reinforcement learning algorithms. Reinforcement learning trains an agent to make decisions by interacting with an environment. Actions are then rewarded or penalized. The strategy is then refined to maximize cumulative reward through trial and error. It's used in robotics, gaming AI, and autonomous driving, where outcomes unfold over time. These algorithms help learn optimal actions without labeled data, adapting through experience rather than instruction. Knowing which category of machine learning algorithm to use to develop an AI model suitable for your task is half the battle. You then have to experiment with specific algorithms to see which creates the most effective AI model. The good news and the bad news are that the list of available algorithms is long. This means that when training your AI model to carry out a specific task, you will first need to prepare your data. Depending on the type of machine learning algorithm you've selected, this may also involve labeling the data. You will then need to use a tool to carry out machine learning, such as the Python programming language and specific libraries that provide the machine learning algorithms you want to use. As we've mentioned, there's a plethora of algorithms to choose from. Even after selecting an algorithm, you must then adjust the available parameters to generate an AI model that meets your needs. Each AI model you generate will then need to be tested with unseen data to verify if the results are as expected. If not, it's time to experiment with different machine learning algorithms or tweak the parameters or training data. This has been Ragdiamond, and thanks for watching this video on What are Algorithms in Machine Learning, a video which is part of my AI Basics series. Please remember to like and subscribe. Your support will be greatly appreciated.